Hey guys, welcome to Inequalities on Graphs, part 1. So these videos are to do with drawing or representing inequalities on graphs and also finding regions that are bounded by them. So in this video we're only going to look at simpler inequalities like x is bigger than 5 or y is less than 2. We will also look at multiple inequalities on the same grid and also double inequalities. So in video 2 we will look at inequalities like y is less than 3x plus 2, things like that, but in this video we are just going to be dealing strictly with horizontal and vertical lines. So let's get cracking. So we need to do a tiny bit of revision before we get going with the inequalities. You need to be really happy at plotting lines on a graph. So as I said in this one, we are only looking at vertical and horizontal lines. So a few examples here. So when we're given x equals a number, those lines are always vertical. So straight up, straight down. So we've got 3 of them plotted here. We've got x equals minus 3 in purple, x equals 0 in green, and x equals 5 in yellow. And then conversely, y equals lines are always horizontal. So in blue, we've got y equals minus 3. Then in purple, we've got y equals 0. And then finally in red, we've got y is equal to 2. So make sure you're happy with plotting lines like that first. And because we're going to be doing that a lot in this video. Okay, the other thing that maybe we need a quick reminder on are the different types of inequalities. So when we have something like x is less than 3, for this first example, that means x is strictly less than 3. It's not allowed to equal 3, but it is allowed to equal anything below it. Then on the flip side, the bottom example here, we've got x is less than or equal to 3. That means x can equal 3 and anything below it. Now it's really important to be able to spot the difference, because when we put these on graphs, we do use different types of lines to represent different inequalities. So when we have a strict inequality, we use a dashed line to represent it. If we have an inequality where our letter is allowed to equal the number, so it's an or equal to inequality, then we use a full line with no dashes in it. Okay, let's get cracking in. So we've got 9 examples. So example 1, find the region satisfying x is less than 2. So the first thing that we're going to do here is plot the line x is equal to 2, which I've already done here. It's this vertical line going up from x equals 2 and also going down. Now it's a strict inequality, so the line is dashed. And finally, we want to find then the region where x is less than 2. So let's think about it. If we were to go to the right of 2 on the number line, are we greater than 2 or less than 2? We're greater, aren't we? So over here, we have our numbers like 3, 4, 5, 6, whatever, anything bigger than 2. But we want x to be less than 2, so we are everywhere over here on the left of our line. So what these lines act as, they act as little barriers between the different regions of inequalities. So to the left of a line, x is less than whatever the number is. To the right of the line, x is greater than whatever the number is. Okay, let's have a look at another one. So example 2, here we've got x is greater than or equal to minus 5. So again, our first move here, we would want to plot the line x equals minus 5, which is already done here. Now it's an or equal to inequality, so it's a full line, and we want x to be greater than or equal to minus 5. So when we're talking x inequalities, everywhere to the right of our line is greater, so we want everywhere over here. We don't want anything over here to the left of our line. Cool. Okay, let's look at a couple y inequalities. So, find the region satisfying y is less than or equal to 0. So, we want to plot the line y equals 0, which remember is just the x-axis. Again, it's an or equal to inequality. So y is allowed to equal 0, so we use a full line. Now we want y to be less than or equal to 0. So when we're talking y values, if we go down, we are getting lesser. If we go above, then our value is increasing. So if we want y to be less than or equal to 0, we want everything down here underneath the x-axis. We don't want anything above the x-axis because everything up there is greater than 0. Okay, the next example, y is greater than minus 1. So this time, we draw a straight line at y equals minus 1, and this time we've got a strict inequality, so our line has to be dashed. So that's already drawn in. Now where is the region that we're interested in? Well, we want y to be greater than minus 1, so that's our values like 0, 1, 2, 3, etc. So that's everything up here above the x-axis. We don't want anything down here below the line y equals minus 1. We want everything above it. Cool. Okay, example 5. Find the region satisfying x is greater than 2 and y is less than minus 1. Okay, so our first job here would be to draw in both of those lines, again, which is already done. So we plotted the line x equals 2 and y equals minus 1. Now, both of our inequalities are strict. There's no or equal to, so both lines here are dashed. Now we want x to be greater than 2, so that means to the right of the red line, but we want y to be less than minus 1. So we need the region that is to the right of the red line, but below the green line. So that's everywhere down here in this bottom right part. We don't want anything up here, because that would be greater than minus 1 in terms of y. We don't want anything over here because that would naff up both inequalities. X would be less than 2 and y would be greater than minus 1. And we don't want anything down here because again x would be less than 2. So we just want this bottom right region. Cool. Okay, example 6. Find the region satisfying x is less than or equal to 5, but y is greater than 4. So again, we've plotted both the lines, x equals 5 in red, and y equals 4 in green. Now the y inequality is a strict one, so the y equals 4 line is dashed. Okay, so let's work out what region we want then. So we want x to be less than or equal to 5. So we know that we need to be to the left of our red line. That's where x is less than or equal to 5. But we want y to be greater than 4. So we are to the left of the red line, but above the green line. So this time, we want everything in that region there. Cool. Okay, on with the next. Okay, so here we want to then find the region satisfying x is greater than 1, but less than or equal to 5. So what we do here, we need to draw two vertical lines, two x lines. So we plot x equals minus 1 and x equals 5. Now, the x equals minus 1 line has to be dashed because we've got x is strictly greater than minus 1. But the x equals 5 line is a full line because x is allowed to equal 5. Now the region that we're interested in is everywhere between those two lines. So everywhere in there. We don't want anywhere to the right of x equals 5 because that's greater than 5. And we don't want anything to the left of -1 because that's less than -1. So we want the region bounded by those two lines. Okay, let's have a look at a y example like that. Okay, so we want to find the region satisfying y is greater than -2 but less than 2. So we plot both lines, y equals -2 and y equals +2. Now they're both dashed because they are both strict inequalities. So the region that we want is the region bounded by both lines. Nothing above the top, nothing below the bottom. Okay, one more example. So here we've got two double inequalities, a double x inequality and a double y inequality. So let's first of all work out the x inequality then. So we want x to be greater than or equal to -4 but strictly less than 1. So we've drawn two red lines, one at x equals -4 and one at x equals 1. Now the x equals 1 line is dashed because it's a strict inequality, but the x equals -4 line is a full line because it's allowed to equal -4. So we already know then that the region we're interested in is between the two red lines. Now let's talk about the y inequality. So we want y to be greater than or equal to 0, but strictly less than 7. So we draw in the lines y equals 0 and y equals 7. The y equals 7 line has to be dashed because it's a strict inequality, but y equals 0 is a full line. So the region that we're interested here then is bounded by both sets of inequalities. So that's going to be this little rectangle here. So between x equals -4 and 1, and between y equals 0 and 7. Okay guys, that's our introduction to plotting inequalities, representing them on grids, graphs. Hope it's helped. Was this video helpful? If so, don't forget to hit the thumbs up button and leave me a comment letting me know how you get on. Also, don't forget to subscribe to the channel so you never miss any videos. For any further information, you can find me on Facebook or Twitter. Search for Maths with Melv. Cheers guys.